Hey ladies and gentlemen, and welcome to the third part of OOP concepts, and in here we will attempt to understand these things here. So these two are just about explaining, these two are about doing. So let's start with the ones for explaining. So what abstraction means is that you hide internal details and of the functionality of your code. So for example, in our application here in the previous video, we created a class called student. And imagine you are the one using the student class here, there's a level of abstraction involved because you don't really need to know what let's say the calculate total result function does. I have no idea what it does. You can imagine if this class was in a different file altogether where I can't really see it here, it doesn't matter what it does. For as long as I call it here, it's going to run the process as expected. Just like, for example, this system.out.println, you've never actually seen the code involved here, but the moment you call it and use it, it works as you intend it to do, provided you follow the rules. So that hiding of code within this is called abstraction. So that's what abstraction does here. So for example, let's say I create an application that creates graphics, okay, and I can give it to a friend. I just say, here's a Java class that provides that can create some graphics for you. All you have to do is use it this way and that way, and it's going to give you this and that. So the user doesn't need to know what exactly it does in there. All they have to do is just create a new instance of that object and then start running it, and it will run as intended, right? So this is the advantage of this kind of thing. You can abstract your code, you can hide the functionality of your actual code inside abstraction. And then encapsulation as well is very similar to the abstraction point here, because it holds everything together. So this is just like binding or wrapping code and data together in the single unit. That's the advantage of this. It makes code cleaner because everything to do with a student in this case is contained within this class. So if I want a way to, let's say, calculate only the English and science results of any student, all I have to do is create a new function that does that within the same class. So then now this class is more powerful than it was before. Then all I need to do is run that function wherever I've used that class before, and I'll get the result I want. So encapsulation helps to put everything together. This is different from when you're just using functions individually, because they'll be all over the place. And let's say you want to move that code to a new project, right? You would have to find all the related functions that are referencing each other and then put them together and then create a new project. But in this case, you know that the student class has everything that you need in order to handle a student. So all you need to do is get the class student, all of it, and then just export it to another project, and it will work immediately because everything it needs is within itself in order to run. All the functions it requires are within itself, all the variables are within itself, so it will just run as you would expect. That's what these two mean. But these other two are a little bit more complex, so let's talk about them. The first one is inheritance. Now there's a lot of nuances to this, so I'm just going to give you an intro of this, and then we will see. We'll run an actual project and then see how these things are useful in an actual project. So inheritance is when one object acquires the properties and behavior of a parent object. So let's say in this case, we have this class student, right? But then I create another class. This one is class John, like so. So John is a particular student. Now, since John is a student, it's only fitting that he should have at least the properties of an actual student, since he is a student, even though this is a very particular student, but he is still a student. So it would make sense if immediately he would inherit a way to calculate his own results, for example, and a way to store his results in the first place, to calculate the total and to store the results. So instead of me having to repeat this, one way to do this is just to grab this and then paste it in there. Now John is a valid student because at least he can store his results and then calculate his total. However, this is wasteful because now I'm repeating my code here and there. Wouldn't it be nice to just tell John that, you know what, just inherit what's inside students, and then I don't have to retype it in here. I can just call this function from John, from John I can call a function that's inside student instead, right? So, and you can actually do that. So I have this empty class here. All I need to do is just say extends and then say student. And just like that, it's done. Now, this is an empty class, but it has the capacity to calculate its total, and it has all this in there already because it's an extension of student. That's how you inherit some properties from another class. So let's try this out here. I'm gonna remove all of this here for a second, and then we're going to instantiate a student class again, but this time this one will not be of type student. This one, oh, my mouse is, what is it doing? Okay, so here we're saying student A is equal to new student, but we'll change this to John. John A is equal to new John. Okay, great. Now let's see if we're going to be able to read his name, his math result, and such. So let's go here. I'm going to say Java C and then app.java. Let's go. And then let's try and run our app. So Java app. And as you can see, it worked just as intended, right? It calculated the total. It shows me the math result and so on from A, but we're saying, but this is of type John. It's not of type student anymore. Okay. But then there's another concept. So this is the concept of inheritance. So in here now I can add extended functionality. So John, for example, can have another one that calculates, instead of total result, it calculates the English and math result. So just like we had here, I can copy all of this and put it in there, but I just want the English and math like so. Now keep in mind we are referencing this.math, which does not exist here, but since we're extending student, we're actually referencing the stuff in there like so. Okay, so now what's happening is that class John extends student, so it has all of the functionality in here plus an extra functionality of itself. So if I create an instance of student, it won't have this function, okay, because the student class doesn't have it. But this one, if I instantiate a John class, it has all of this plus what it has within itself. So this is the beauty of inheritance, because I don't have to retype all of this in here plus the extra stuff. I just have to tap the extra stuff and then say get everything that's from here, and then I'll add on a few things in there. So this may not seem very powerful in here, but it is. When we do an actual project, you will see how that works. And then finally we have this idea called polymorphism. This means you can perform one task in different ways. So let's see in here, I have this calculate total result, right? Or the thing is, within Java, you can repeat two functions with exactly the same name like this. So calculate total result and calculate total result, right? Now in here though, I can't have them just like this as they are. They have to have a different signature. And how to put a different signature is what is required here. So here maybe I require a boolean. So I'm going to say boolean I'm going to call this one include math, like that. Okay. So in here, we're calculating the result, but I have a version that I can choose whether to include math or not. So here I can ask the question and say, if include math. Now this, just by saying include math, is the same as saying include math is equal to true. Now we haven't done if statements yet, but here I'm just showing you a possibility, so just bear with me. This is an if statement where we say include math is equal to true. If we want to include math, let me do this. So we will deal with if statements next, so just bear with me here. And then there's an else statement. So all I'm doing here is asking the question that, is this value true or false? Because Boolean has true or false. And then we can use it. So if including math is true, which means we should include math, then we return that. If it's false, we don't return math together as a result. So we just remove that math there. So that's just an if statement saying, if you want to include math, let's return that. If we don't want, let's return that. So we have a Boolean here. Now, these are two exact functions. The only difference is that if I pass in a value while calling this function, then it's going to run this function instead because it matches the signature. And it will even look at the type of data that I've supplied. If I supply true or false, it will say, oh, he wants to run this version of the function, so it will run this one. If I don't supply anything, it will run this function instead. But then I can even put a third one where I include a string here instead of type string. Then if I try to call this function and include a string in there, it will run this version that matches that signature. So by doing so, this is called polymorphism. So if I check here where I say calculate the result and then I say false in here, I put false. This false is going to be put as 1. It will mean that I'm trying to read this one, and then it will return a result that does not include math. So let's do a javac app.java to see that. And then let's run java app like so. And you see now the result is different. It's 130 instead of 220 because we omitted the math in that second calculation, because it ran this version of the function instead of this one. Now this ability to have the same function do two different things is called polymorphism. Same function name, but it can do two different things, polymorphism. Now the same thing can apply even to classes, and we're going to see how that applies later. This action right here is called method overloading because we are using a method in more than one way, so we are overloading it, so it's called method overloading. There's also method overriding when creating instances, but we will see that in a later tutorial. For now, this was method overloading, which is part of polymorphism, doing more than one thing. This is just like poly means many, and this one means forms. So many forms, that's what it means, many versions or something like that. All right, so this is all about OOP concepts. Now we're going to go into actual practical content. So from here, we're going to learn a bit about loops, if statements, and calculations, the basics, and then we'll go and create an actual practical project where we have user logins, save data, etc., etc. All right, so I'll see you in another video.